Pose with the fans. Pose with the pose with the pose with the fans. Pose with the pose with the fans. Pose with the fans. Pose with the fans.
Hello, my name is Afi and I will explain about differentiation and technique of differentiation. First, differentiation. Differentiation in mathematics is a technique used to find instant rate of change of function. This is done by finding the derivative of the function, which represents the slope of the tangent line at any point on the function graph. There are various rules and methods used in differentiation, which is we know as technique of differentiation. So what is differentiation? Differentiation is in math is basically like fx in differentiation, fs in differentiation. When we derivative, it become f prime x.
For technique, we got 7. First is power rule, product rule, quotient rule, chain rule, and then another 3 is implicit differentiation, logarithmic differentiation, and parametric differentiation. And that is the explanation of differentiation and technique of differentiation. Now we got 3 example questions, and I will pass it to my friend.
So let's answer for question number 2, and that is to find dy divided dx for the function a and b. Let's start with function a first. So function a, I have y equal to 5x to the power of 3 multiply tan x plus 2. This is a product of two functions, and that is 5x to the power of 3 and tan x plus 2. So I will use the product rules, and that is dy divided dx equal to u prime multiply v plus u multiply v prime. So divide the two parts, u equal to 5x to the power of 3 and v equal to tan x plus 2. And for the derivative of u, which is u prime, will be equal to 15x to the power of 2, while the derivative of v, which is v prime, will be sec to the power of 2x plus 2. And now I will substitute the values into the formula. dy divided dx equal to 15x to the power of 2 tan x plus 2 plus 5x to the power of 3 sec to the power of 2 x plus 2. And that is the final answer. For part B, I will given the function y equal to sin x divided 2 minus 4x. This is a quotient rule, meaning it will be dy divided dx v multiply u prime minus u multiply v prime divided by v to the power of 2. Now let's define the numerator and denominator. Let u equal to sin x and v equal to 2 minus 4x, and the u prime will be equal cos x and v prime is equal minus 4. Substitute it into the quotient rule, and it will be dy divided dx equal to 2 minus 4x cos x minus sin x minus 4 divided by 2 minus 4x to the power of 2, and simplify the expression, and it will be dy divided dx equal 2 minus 4x cos x plus 4 sin x divided by 2 minus 4x to the power of 2. And that is the final answer.
Okay, now we move to question 3, which is y ln 2x minus exponent power of 3x plus y minus cosine 4x equals to 0.
Let's continue to find the a prime, b prime, and c prime. Let's look for a first. We have y ln 2x. So here we need to use the product rules because they have a function inside log. That's why we need to use the product rules. This formula, which is u multiply with v prime plus v multiply with u prime. So let's look for u. What we have? U, we have y. So after we differentiate, we have u prime, which equals to dy over dx. So for v, we have ln 2x. So we differentiate, we have 1 over 2x multiply with 2. So the final answer for v prime, we have 1 over x. So our a prime, we have y over x plus ln 2x
dy dx.
b, we have exponent power of 3x plus 1. Here we need to use the chain rule for 3x plus 1. So after we differentiate, we get the 3. b prime, we have exponent power of 3x plus 1 multiply with 3. The final answer for b prime, we get 3 exponent power of 3x plus 1. So last, we need to find the c prime. C, we have cosine for y. And first, we need to differentiate the cos. We get negative sign. For y, we get 4, and y, we get dy over dx. So the final answer for c prime, we get negative 4 sine for y dy over dx. Next, after we have done for the a prime, b prime, and c prime, we need to solve it. A prime minus b prime minus c prime equals to 0. So let's substitute y over x plus ln 2x dy over dx minus 3 exponent power of 3x plus 1 plus 4 sine for y dy over dx equals to 0. So next, for the next step, we need to separate the dy over dx in right. So right, we have ln 2x multiply with dy over dx plus 4 sine for y dy over dx equals to 3 exponent power of 3x plus 1 minus y over x. And lastly, we need to move the right equation to the left. So we need so in the right, we just have the dy over dx equals to 3 exponent power of 3x plus 1 minus y over x over ln 2x plus 4 sine 4y.
So now we're on question 4. So the question is, use linear approximation to estimate the value of 2 over square root of 80.99 minus the fourth root of 80.99. So first and foremost, we should know the definition or the basic for linear approximation. Well, linear approximation is a method we can use to estimate the value of a function near a specific point. It's especially helpful when calculating the exact value of the function when it is difficult or time-consuming. By using the tangent line at a known point, we can get a close approximation of the function's value nearby. So now we're on the calculation section. So we have three parts, which is derive fx, find fx and f prime x, and then the final one, which is use linear approximation formula. So now we're on the first step, which is derive fx. So before doing anything, we should rewrite the equation using exponent so it would be easier for us to derive it. After rewriting the equation, now it's time for us to derive the equation. Now it's time for the second step, which is find fx and f prime x at x equal to 81. Well, you might be asking, why are we using 81 instead of 18.99? Well, we're using it because 81 is a much more cleaner number and it's close to 80.1. So now we're on the last step, which is use linear approximation formula. So the formula is fx plus f prime x times x0 minus x. For your information, the x0 is the original number that we're trying to approximate, which is 80.99. So after doing the calculation using the formula given, the answer should be negative 2.778.
So this is our reference that we have got during creating this video assignment.
So, is there any question? Well, it looks like I'm all alone here, so I think that's all from us. Thank you.